Okay, it is around 1:03 p.m. Now we can start the class. I can see that around 8 to 9 people have joined. So what you all do is that please give your attendance in the chat box. Write your class roll number. Give your attendance in the chat box. Write your class roll number. Let me present my screen first. Can anyone confirm me whether my screen is visible to you or not?
Yes, sir.
Yes, sir.
Visible.
Yes, sir.
Can you see the slides?
Yes.
Okay. So let me give you a brief recap or a summary kind of thing of what we discussed in the last class. We have discussed about different types of elements that we use to analyze any given structure in FEM. We discussed about one-dimensional elements, two-dimensional elements, as well as three-dimensional elements. Also, we have seen different types of one-dimensional, two-dimensional, and three-dimensional elements that we use to model any given structure. And we also discussed that the modeling of the structure will depend on the geometry according to the shape and size of the geometry. According to the shape and size of the geometry, I have to decide whether I have to discretize my structure with the help of 1D element, or with the help of 2D element, or with the help of 3D element. And then we also discussed about what is the difference between FEM and FDM. And we in the last class we covered till this topic. So in today's class, what we will do is that we will discuss about what are the advantages of using finite element analysis. What are the advantages of using finite element analysis? It is very much simple. If you read the first point, what is written, that finite element analysis, that is FEA, is applicable to any physical problem like stress analysis, fluid flow problems, heat transfer problems, electromagnetic field problems. That means by the use of FEM, we can solve any domain of problem, whether that domain can be of electrical domain, can be of mechanical domain, can be of electronics domain. There is no restriction about the geometry of the component. Component can have any complex shapes. This is also true. We can analyze, we can solve any given component of any given shape by discretizing that component on the basis of different types of elements. There is no restriction on the location of loading and the boundary conditions. This is also true. We can solve any kind of problem. We can solve any kind of problem with any given boundary condition or any given loading condition. In the given problem, I can change the loading condition as well as I can change the boundary condition also. Then also I can solve the problem by the help of FEM. Isotropic, orthotropic, as well as composite material properties may be used. That means by the use of FEM, we can solve any given problem made up of different material properties. If I talk about isotropic properties means all the in all the direction material of the property is same. What is orthotropic property? Orthotropic property means in all the directions material of the property will be different. So all these type of problems, as well as the composite material problem, that means if a machine member is made up of different composite materials of element, that also we can solve by FEM. Material non-linearity can also be incorporated. We have seen that if the material is non-linear in nature, we can use non-linear finite elements to discretize the given problem. Parts that have different physical behaviors and different geometrical descriptions can be combined and analyzed. If I am having a composite problem, if in that composite problem one part is made up of one material of one length, and the second part is made up of some other material, some other length, that means that is a composite problem, that also I can combine and I can solve the problem in FEM. The desired accuracy can be achieved by implementing an adaptive meshing scheme in which a mesh can be revised. That means by changing the mesh, we can get the desired accuracy level for analysis of any type of problem. That means we can refine the mesh by the help of FEM. If I talk about some commonly used FEM packages, those packages are ANSYS, Nastran, Abacus, Algor, Adams. These are the common softwares which we can use to solve FEM related problems. Is the advantage slide is clear? किसी को कोई doubt है slide में? Hello.
No, sir. No, sir.
नहीं सर.
Okay, fine. Next, let us come towards the application areas of finite element analysis. That means what kind of problems we can solve or we can deal with finite element analysis. Basically, we can solve three type of problems. First one is static problem. Second one is eigenvalue problems, and third one is transient problems. Transient problems is not there in my syllabus. We will be dealing with static problems as well as eigen problems. So, what are these static problems? Static problems are those problems, in static problems, boundary and loading conditions applied on the structure do not change with time. That means if you are having one problem, if in that problem loading condition as well as the boundary condition, if it does not change from time to time, then that type of problem is known as static problems. And some of the common static problems that we solve in FEM are static analysis of truss, beams, plate, shells, static analysis of aircraft wings, rocket, etc. We can analyze in this static part. We can also analyze the stress concentration. For example, if we are having a plate and if I make a small hole inside the plate, then how to model that structure, which portion will be subjected to maximum amount of stress, that also we can analyze over here. Analysis of pressure vessels, that also we can do by the help of which element? Axis symmetric element. In the last class I have told you that pressure vessels, rings, all these are axis symmetric in nature, so we can analyze these problems by the help of axis symmetric elements. If I talk about eigenvalue problems, what are these eigenvalue problems? In eigenvalue problems, only boundary conditions are considered, neglecting the applied external load. That means in static problem, what we were doing, we were considering the boundary conditions as well as the loading conditions, but both the conditions were not varying, they were not varying with respect to time. But in eigenvalue problems we are interested in only the boundary conditions, we are not interested in the load, whether the external load is applied on the body or it is not applied on the body. We are not interested in that thing. What we are interested in about only the boundary conditions. On the basis of this, if we try to solve those kind of problems, those problems are your eigenvalue problems. Generally, the vibration related problems are your eigenvalue problems, where we can find out the natural frequencies of different types of structures. It can be an aircraft, rocket, missiles, etc., by the help of these eigenvalue problems. Similarly, you can find out the natural frequencies and stabilities of linkage, gear mechanisms, machine tools, etc. Third variety of problem which we can solve by FEM is the transient problems. What are these transient problems? In transient problems, either the boundary conditions or the loading conditions or both vary with time and response of the structure is observed over time. In that means what kind of problem we deal with transient problems? In transient problems, either boundary condition will vary with time or loading condition can also vary or both can also vary. Then those type of problems we call it as transient problems. And what kind of problems we solve in this? Yes.
Sir,
Hello.
sir, in eigenvalue problems, the boundary conditions vary with time.
Yes, in
Obviously.
eigenvalue problems, we will only consider when we will take boundary conditions. That boundary condition may vary, may not vary, but we will not consider the loading conditions. For example, if I am having a beam, if I am having a simply supported beam, on that simply supported beam, if I apply a UDL, then that beam will bend. I have to find out by the help of FEM what is the nature of that bending phenomena. I will not consider in that case the load. I will consider that the beam, since it is a simply supported beam, that beam is fixed at both the ends. With the help of that boundary condition, how I will model my problem. That boundary condition can change with time. Say after time t equal to 10 seconds, you can remove that boundary condition. You can remove that that boundary condition. You can say that okay, I am applying or I am fixing my beam at the middle point. That also you can do. That is your eigenvalue problem. Is it clear?
Yes, sir. Yes, sir, it's clear. Yes.
And what about transient problems? In transient problems, either boundary condition can vary with time or load can vary with time or both can vary with time. Fine. In static problem, they does not, both the boundary conditions as well as loading conditions, they does not vary with time. In eigenvalue problem, only you have to consider the boundary conditions, loading conditions. You will not taken into account while solving these problems, but that those boundary conditions can vary, cannot vary with time. And in transient problems, both can vary as well as anyone can also vary. Fine. And some common examples of these transient problems are your propagation of stress waves. For example, if you are having say a wire, if you say give a small vibration to a wire, it will form a wave kind of nature. You can analyze those kind of things in this transient problems. But in our course, in this BTech level course, we are not interested in these transient problems. We will be interested in only solving the static problems as well as the eigenvalue problems. These are the these are some of the common application areas of finite element analysis. Many more application areas are there that you can get in the book. Already I have given you the PDF copy of that book in your Google Classroom. You can, if you want to know some more applications, you can refer the book. Is the application part clear? Any doubt?
No, sir.
Okay. Next is the history of FEM. In this slide, nothing much I have to say. See, in this slide, what they have been discussed is what is the history behind FEM. When FEM firstly when it has been discovered, at that time what happened, then year by year what all modifications we have did in the FEM, all those things are described in this slide. You can see that in 1940 it was first discovered in the year of 1940, and during that time FEM was used to solve structural engineering problems. Similarly, if you say in 1950, what happened in 1950? By the help of FEM, people derived the direct stiffness matrix for two-dimensional elements. Likewise, if as the year progressed, say if I talk about 1962, in 1962 then material non-linearity came into picture in FEM. That means if any non-linear material is there, how we can model that material in FEM. Likewise, for different likewise, if you see different years, FEM has evolved and has given you some applications. In the present days, many new type of elements have been discovered, as well as new softwares has been discovered. Earlier we uses only say ANSYS, but now Abacus is there, Algor is there, Adams is there, in which you can write the code and you can analyze the structure. Clear? This is the brief history of FEM. It was discovered in the year of 1940. Then in subsequent year, what all discoveries happened, that is there in this slide. For more information, you can refer net, you can refer books also. That will help you. Is it clear? Without any call?
No, sir.
Okay. Okay. Next and the last part of module number 1. And this part is completely the numerical part. Till this much part, till this history part, everything we discussed in terms of theory. One problem was there, that is the cantilever beam problem. I made you solve that by the help of FEM, how we can solve that problem. Fine. And this is the last part of module number 1. This is completely the numerical part. Fine. That is the approximation methods for solving differential equations. What are the different approximation methods available in FEM to solve different types of differential and integral equations? Let me tell you that in order to understand this, all these methods, you should be good enough in differentiation as well as integration, because in all these methods we will be talking about the differentiation as well as integration. So you should be well known with different types of differentiation formulas as well as integration formulas. Fine. Now what this topic tells you, let me give you an example and then it will be clear to you that what we will be studying in this topic. Okay, wait. Can you see my white screen?
Yes, sir.
Okay, okay, fine. So if I take a beam, say this is a beam, this is a simply supported beam. That means beam is having support at the two extreme endpoints. And if I apply a load, external load on the beam, any kind of load you can apply. You can apply a UDL also, you can apply a UVL also. But the thing which I am trying to say is that due to application of any kind of load, whatever beam it is, the beam will bend, the beam will bend, the beam will deflect. So you can assume that this is that deflection curve. Fine. This is this deflection curve. If you see this curve, this is that curve. Fine. Now this curve is having some pattern, or this curve will follow some equation. That equation can be a polynomial equation. That equation can be a trigonometric equation. That equation can be an integral equation. That equation can be a differential equation. One more example, let us take, say this is a cantilever beam. On this cantilever beam, I have applied a load at the end point. As a result of it, the beam will deflect. So if I draw the deflection curve, this will be the deflection curve. Fine. That means the pattern of this problem, that means the deflection curve of this problem is somewhat like this. Now this curve can be quadratic poly, can be a it can satisfy a quadratic equation also. It can satisfy a cubic equation also. It can satisfy a higher order equation also. It can satisfy some tangential curve also, cosine curve also. I don't know. Fine. But what I know is that if I apply any external load on any static member, whether it can be a beam, whether that can be a truss, or it can be a cable, the beam will deflect. If the beam is deflecting, that means that if I follow the deflection pattern, I will get some kind of curve. Those curves can be in form of integrals, integral equation. It can follow some differential equation pattern of curve. It can follow some polynomial pattern of curve or some trigonometric pattern of curve. So if I assume that this pattern is following some differential equation, if the pattern is following some differential equation, then how to solve such problems by the help of FEM. That means how to get that what is the nature of this displacement curve. What is the nature of this displacement curve? Whether it is linear in nature, or it is quadratic in nature, or the nature is sinusoidal, or the nature is tangential. How I will depict? For that, I have to use some approximation methods that are available in FEM. Those approximation methods are weighted residual method, Rayleigh-Ritz method, and variational method. Inside weighted residual methods, there are 5 sub methods. Those are point collocation methods, subdomain collocation methods, least square methods, and Galerkin methods. By these methods, we will find out what is the nature of this curve, whether it is polynomial, whether it is trigonometric, or it is somewhat else. Is the concept clear? What we will be doing in this part? Any doubt?
No, sir.
Fine. Okay. So let us take any problem. Now this problem here I have talked about the static structural problem. If I take heat transfer problem, for example, if I am having say a metal, this is one metal. If on this metal, if I put a candle over here, and if I say this is the flame of that candle, if I try to heat this metal, then I know that due to conduction phenomena, that means due to the Fourier law of heat conduction, the entire body will get heat up after some time period. Then after some time, if you touch this end of the body, you will feel that this end of the body is you will feel the hotness. Fine. Again, this problem is based on some governing differential equation. What is that governing differential equation? That governing differential equation is nothing but Fourier's law of heat conduction, which is nothing but Q is equal to minus K times of A dt by dx. That means the temperature profile, or that means the temperature profile for this particular problem will follow this governing differential equation. For a beam, for a static problem, if the beam is bending, then I know that e into I d2y over dx2 is equal to m. That means this equation you have to follow. This is the bending equation. Fine. That means this is what? This is nothing but the governing differential equation for a static beam problem if the beam is undergoing deflection. This is the governing differential equation for heat transfer problem. Which type of heat transfer problem? Conduction heat transfer problem. So these governing differential equations will be given to you. If not given to you, you have to understand the problem, wording of the problem. Then from that problem, you have to derive the governing differential equation. You have to write the governing differential equation. After that, you have to choose any one method to get the, say in this method I will get the temperature profile. I have to use all those methods to see what is the temperature profile for this problem. I have to use all these methods. Which methods? These methods, to see what is the displacement profile for this problem. This is basically what we will be doing in all these methods. Now there is certain rules or certain procedure to solve problems for different methods that we will discuss now. Is the concept clear? क्या किसी को कोई डाउट है कॉन्सेप्ट में?
No, sir.
Okay. So let us first understand what is weighted residual method. Before understanding what is weighted residual method, let us take a differential equation, a governing differential equation for a problem. That problem can be a structural problem. That problem can be a heat transfer problem. That problem can be a fluid flow problem. For example, if you are having a pipe, in that pipe, if a fluid is flowing, then there is some equation, some governing differential equation on the basis of which that fluid flows inside a pipe. Fine. So here what I am doing is that I am taking a general governing differential equation. This equation is valid for all the type of problems. And let us see how the physics of the problem, or let us see what all things are present. What is this term? What is this term? What is this term in this problem? Then only we will be able to apply all these methods, because ultimately we have to apply all these methods for a given differential equation which satisfies the boundary condition for your given problem. Fine. So let us consider a differential equation of the form minus d over dx of a, which is a function of x, into du dx equal to q of x. Let this to be equation number 1. Now in this equation, your x varies from 0 to L. If it is a beam problem, if this governing differential equation is a bending of beam problem, then the domain is what? Domain of the problem is x can vary from 0 to L. That means length of the length of the beam can vary from x equal to 0 meter to x equal to L meter. If I talk about heat transfer problem, the element on which you are finding out what will be the temperature profile, fine. In that case, this x will vary in terms of temperature. That means x is equal, value of temperature is 0 when x is equal to 0. Value of temperature is T when x is equal to L. So this 0 to L is nothing but the domain of the problem. Is it understood? And this domain will vary from different types of problem. For fluid problem, domain will be different. For static structural problem, domain is different. For heat transfer problem, domain is different. Is it clear? कोई डाउट है किसी
Yes,
को?
sir. No, sir. No, sir.
Okay. Now, this governing differential equation, whatever problem you take, it is valid for some boundary condition. Because otherwise, if you don't provide boundary conditions, you cannot solve these differential equations. Fine. In order to solve this differential equation, which is satisfying one problem, you need to provide some boundary conditions. So in FEM, we are having two type of boundary condition. One is the essential boundary condition. Second one is the natural boundary condition. Can you tell me what is essential boundary condition and what is natural boundary conditions? Because I think you have studied the differential equation part in mathematics. So I hope that you might be knowing what do you mean by essential boundary condition for any problem, any differential problem, and what do you mean by natural boundary condition? Can anyone say what are these things?
So natural boundary condition means when you consider a uh, particular material, naturally it exists a certain length and a certain dimensions that exist naturally, which we cannot change if we consider for that particular material.
That means
And
what you are telling is that natural boundary condition is present in the problem itself. We have to find it out from the problem.
yes,
That
sir,
is what you
yes.
are trying to say?
So the end conditions that the problem has.
End conditions of the problem. That means, so, fine, okay. And what is your essential boundary condition?
Sir, we assume this one that if we take it from a certain, we can say a certain origin, then
For
what
example,
will be?
okay, let me give you an example. For example, if I am having a cantilever beam is fixed at one end. The end which is fixed, I can say that at that end or on that node point, deflection will be zero. Can I say that that is my essential boundary condition?
Yes, sir. Because you are
Yes,
imposing it
yes.
externally, so it is a
That means
essential
that
boundary
means
condition.
essential boundary condition is that boundary condition for any differential equation. Without that, you cannot solve the differential equation. You have to apply this essential boundary condition in your given differential equation to get the solution. But once you use this essential boundary condition in your given differential equation to get the solution, in that solution you can see in direct form or in indirect form this natural boundary condition. That is the difference between essential boundary condition and natural boundary condition. In order to solve a differential equation, you have to give one boundary condition always, and that boundary condition is essential boundary condition. And natural boundary condition is what Shomnath just now said, the end conditions of the problem that will be given to you in the problem. If not given to you, from the structure you have to identify what is the natural boundary condition. Is the concept clear? Difference between essential and natural boundary conditions, because
Yes,
we
sir.
will be
Ji, sir,
using
ji.
these two boundary conditions frequently while solving different problems. Okay. So let us assume that for the given differential equation, my boundary condition is, if I assume that this boundary condition is applicable for this cantilever beam problem, that means in this beam problem, what is happening? Displacement is happening. So this u is nothing but a function of displacement. Fine. That means this u can be a quadratic polynomial, can be a cubic polynomial, can be a sinusoidal equation. I don't know. I have to find it out. Fine. So this u is nothing but displacement for that problem. So the essential boundary condition is value of this displacement will be equal to u naught when x is 0. U of 0 is equal to u naught is what? U of this, in bracket I have written 0. This bracket is nothing but the value of x. That means when x is equal to 0, displacement will be equal to u naught. That means if I define this essential boundary condition for this problem, x is nothing but the length of the beam. When x is 0, that means this point, when x is 0, displacement u is nothing but u naught. And definitely by looking at this problem, displacement u naught will be equal to 0. Is it clear? Understood?
Ji, sir.
Fine. Likewise, this boundary essential boundary condition will change from problem to problem. Fine. Okay. And what is the natural boundary condition? So if I am talking about displacement, this du by dx is what? Slope. slope of the deflection curve, fine, then slope of the curve will be equal to how much, will be equal to capital Q naught at x is equal to L. That means for this problem, if I want to define what is my natural boundary condition, when x is equal to L, that means at this point, x is equal to L, because x varies like this. X is what? X is nothing but the length of the beam. Fine. When x is equal to L, the slope of the curve, that is du by dx at x equal to L, is nothing but Q naught. This is my natural boundary condition. Is it clear what is essential boundary condition and natural boundary
Sir,
condition?
can you please repeat the natural boundary condition once again, sir?
Natural boundary condition means, say this is my deflection curve. Okay, this is my deflection curve. Fine. X varies from x equal to 0 to x equal to L, which is nothing but the length of the beam. Fine. Now, natural boundary condition is what? Now, I can see that due to application of this load, beam will bend like this. Beam will bend like this. At x equal to L. At x equal to L. That means at this point on the deflection curve, if I find out slope of the curve, that is nothing but rate of change of displacement, that is du by dx, that value is given to me as q naught. At x equal to L, displacement is q naught, or at x equal to L, du by dx is q naught by a. अब clear हुआ?
Yes, sir.
That means at this point, at this particular point, if you find out the value of slope. So this is essential. And so from equation number 1, what are the known things given to you? These known things are nothing but the data of the problem. That means a of x is given to you, will be given to you in the problem. Q of x will be given to you in the problem. U naught, that means this U naught, will be given to you in the problem. Capital Q naught, that means this capital Q naught, is given to you in the problem. And L is what? L is nothing but the length of the beam. If I talk about that cantilever problem, again it is given to me in the problem. These things are nothing but the data of the problem. If these things are not given to me, I can never solve this differential equation to get the pattern of the displacement curve. Fine. Now, what is this AX? What is this small qx, u naught, capital Q and L? That will vary from problem to problem. If the problem is structural analysis, these things will vary. A will be something else, Q will be something else. If you are dealing, say if this differential equation is satisfying some heat transfer problem, these values will be different. If this differential equation is satisfying some fluid flow problems, these values will be different. Now in the next slide, I will let you know what are these AX, QX, U naught, Q naught and L. Is the slide clear? क्या किसी को कोई डाउट है स्लाइड में? Hello.
No, sir. No, sir.
Okay. Let me move forward. Fine. What is this x? This x is nothing but my independent variable. What is u of x? U of x is nothing but my dependent variable, because on the value of x, your u will depend. For example, at x equal to 0.2 meter, what is the value of displacement? Ux. So that's why ux is dependent variable, x is your independent variable. And what is this 0 to L? The 0 to L, 0 to L is nothing but the domain of my problem. That is maximum portion of my problem. What is 0 is the
Sir,
minimum.
range.
डोमेन मींस इफ नो, अगर आप उस हिसाब से जा रहे हो कि अगर आप फंक्शन के हिसाब से जाते देख रहे हो मैथमेटिक्स में, डोमेन रेंज वो अलग कॉन्सेप्ट है. यहाँ पे कॉन्सेप्ट, यहाँ पे मैं रेंज नहीं बोलूंगा.
अच्छा
यहाँ
अच्छा
पे मैं एफईएम में
ठीक
बात करूंगा. डोमेन मींस द मिनिमम पॉसिबल लिमिट ऑफ द प्रॉब्लम टू द मैक्सिमम पॉसिबल लिमिट. यहाँ पे उसको आप कंफ्यूज मत करो मैथमेटिक्स में फंक्शन से. रेंज अलग हो जाएगा, रेंज एफईएम में अलग होगा, डोमेन अलग होगा. ठीक है.
ठीक सर.
Okay, fine. What is our aim? Our aim is to find u of x. That means what is the pattern? whether it is following a cubic pattern, quadratic pattern, or some sinusoidal pattern. That is what I have to find it out. That is my main motive of this problem. Fine. Now, I told you these AX, QX, U naught. That means this data of my problem that will vary from problem to problem. Now, if the problem is of cable, that means you are having a cable or a beam, fine. Then what are these values? U will be nothing but deflection. A, this way A, that means this A in the question will be nothing but tension. What is the tension in the cable? Q of X, that means this Q of X will be nothing but the transverse load on the cable. If you are applying any transverse load on this cable or beam, that will be the value of this Q of X. And what is Q naught? That means this Q naught. What is this Q naught? This Q naught is your axial force. If you are taking a cable problem or a beam problem, these are these values. If you are taking a bar problem in tension or in compression, then again you will be deflection. This small a, that means this small a will be nothing but multiplication of E into A, where E is the modulus of elasticity of the bar and A is the cross-sectional area of the bar. That means if in the question it has been told to you that find out the approximate solution by considering one suitable differential equation for a bar problem, then then you have to use this differential equation. In place of AX, you have to write EA. Similarly, what is small qx? That means the small qx, that is nothing but the frictional force, if any, present in the bar. And that is also known as traction. In FEM, that
Sir, what
frictional
is A, sir? What is A? Small A?
small a is the material property, for each and every type of problem. If I am talking about bar, material property is your E into A. E means the modulus of elasticity of the problem into cross sectional area of the problem. What is this
Okay,
QX?
okay, sir.
QX
Okay.
is your frictional force, if any, present in the problem. For example, say this is my bar, this is a cantilever bar. On the extreme, on all the edges of the bar, if I apply some frictional force, that is nothing but QX. And in FEM, we call this frictional force by a new term called traction. We will not call as a frictional force, we will call it as a traction force. That is qx that you have to substitute over here. And what is q naught? This q naught is the axial force. That means in this problem, if I apply say axial force of p, then that q naught will be p. If the same differential equation if you use for heat transfer problem, your u will be what? Your u will be temperature. How the temperature profile is varying, then in place of u you have to write t, dt by dx. What is A? The small a. Again, I told small a is the property. Then, in case of heat transfer, property will be thermal conductivity, K of the problem. What is small qx? The small qx is the internal heat generation. Internal heat generated in the problem. That is small qx. And what is this capital Q? This capital Q is your the heat, overall heat generated in the problem, overall heat of the problem. Fine. So if I am giving you some heat conduction problem, you have to change your differential equation in this manner by substituting the proper terms.
Sir,
Similarly,
the differential equation pattern will be the same in that is given in the this slide. Just
pattern can be given in the problem, may not be given in the problem. If it is
okay,
not
sir.
given in the problem, you can take this pattern, and if the problem is of heat transfer, you can substitute the values. If the problem is of bending, say a cable which is undergoing bending, or if it is undergoing some deflection, you can change the pattern. I am telling you in that case when the differential equation is not given to you, then Then what is this thing, what is this value, what is this value, then I am telling to you. If the differential equation is given to you, then not an issue, you will use that same differential equation and you will solve the problem. If it is not given to you, then how to identify all these things, that is what I am telling over here. Is it clear?
Yes, sir.
ठीक है, okay. And similarly that same differential equation I can write for fluid flow problem also. That means if I am having any laminar incompressible flow through a pipe, then also this equation is applicable, but something will change. What all things will change? These values will change. So in that case, what will be u? U will be your velocity, because when you flow some fluid inside a pipe, normally you are interested in velocity profile. So your u will be your velocity. What is a? A is nothing but the property. In this case, property will be viscosity. Viscosity, fine. So that will be eta. You have to replace a by eta. What is small qx? That means the small qx, this is nothing but pressure gradient developed in the problem. And what is the capital Q naught? Capital Q naught is the axial shear stress, because fluid is subjected to a shear stress. What is the axial shear stress present in the problem? That you have to replace this value with Q naught. Is it understood? These type of problems normally we will deal with FEM. So if any differential equation is not given to you, you can frame the differential equations by these things. Clear है? कोई डाउट है किसी को? किसी को कोई डाउट? कोई डाउट है
No,
किसी को? Okay, okay, fine. Sometime in the problem, differential equation can be given to you, sometime it may not be given to you. For example, I know that if I am having any beam and if that beam deflect, that deflection phenomena follows some governing differential equation. I already know, I have studied from the concept of strength of material, and that differential equation is EI d2y by dx square equal to m. So in that case you have to use this formula, because this is a common formula. Similarly, if in that same problem shear force is acting, due to shear force deflection is happening, then you have to change the governing differential equation. That differential equation becomes EI d cube y by dx cube is equal to S. S is your shear force. Fine. If simple load is acting on any beam and then the beam is deflecting, then again that governing differential equation will be changed. What is that equation? That equation will be EI d4y by dx4 is equal to load. Fine. So you have to read the problem carefully. If the differential equation is given to you, well and good. If it is not given to you, according to the statement of the problem, you can use either of these three equations, or else you can use this equation. This equation. Clear? Any doubt?
sir, 1 minute.
I will give the recorded lectures. I will give the recorded lectures in the Google Classroom. Don't worry. Today by day end, I will give today's lecture also, as well as I will give yesterday's lecture also. This part is little bit complicated part in module number 1. इसके पहले तक तो थ्योरी था, तो उसमें तो आप लिख सकते हो कुछ भी, लेकिन यहाँ से न्यूमेरिकल पार्ट चालू होता है, तो थोड़ा सा कॉम्प्लिकेटेड पार्ट है. आगे बढ़े. हेलो.
Yes, sir. Yes, sir.
ओके ओके फाइन. बाकी लोगों को समझ में आया यहाँ तक?
Sir, there is one doubt that the initial differential equation which was given, and then you are
Yes.
replacing every type of it. Sir, this
Yes.
is general. This we will be using everywhere if differential equation is not given to us.
See, if differential equation is not given to you and you don't know the phenomena of the problem, that means whether in that problem bending is happening or torsion is happening, or that problem is undergoing say it is a problem of heat conduction equation. If the phenomena is not given to you in the problem, then you can use this general differential equation. But if the phenomena is given to you, see, this equation is valid for some phenomena. This equation is valid for some phenomena. This equation is valid for some phenomena. Then you have to use this equation. Is it clear?
Yes, sir. Yes, sir.
Yes, sir.
बाकी लोगों को कोई डाउट है कब यूज करना है कौन सा डिफरेंशियल इक्वेशन अगर नहीं दिया है तो कोई डाउट किसी को हेलो बाकी लोगों को कोई डाउट है किसी को
No, sir.
नहीं सर,
Okay,
नहीं सर.
fine, fine. Now we are in a position to explain what is weighted residual method. Fine. So let us discuss what is weighted residual method. All these methods, whether you talk about weighted residual method, Rayleigh-Ritz method or variational method, these are approximation methods to solve a given set of differential equation satisfying your given problem. That means with the help of these methods you will not get the exact solution, but you will get the approximate solution which will be very much nearer to your exact solution. Fine. Okay. So what is my weighted residual method? In the weighted residual method, the first step is the physical problem is represented by differential equation with boundary condition. That means this is the first part. You have to represent the given problem by the help of a given set of differential equation with the boundary condition. This condition may not be given to you, not an issue, but you have to give this boundary condition. That is the essential boundary condition. If it is given in the problem, well and good. If it is not given in the problem, you have to see the problem. Accordingly, you have to frame your essential boundary condition. This is the first step of weighted residual method. What is the second step? Second step is what is our aim? Our aim is to find out the approximate solution of the given differential equation. Let us assume that the given differential equation is this. That is del 2u by del x2 minus del u by del x equal to fx. This is one form of this general differential equation, which is valid for a problem. Fine. I can also write this differential equation, that is equation number 1, like this. That is LU is equal to F. What is L? L is nothing but del square by del x square minus del y del x. This is known as differential operator, which I have operated over variable u. So from the concept of mathematics,
So,
I can... Hello?
sir, this equation, this differential equation, the partial differential equation, this is
Yes.
for the weighted residual method only.
No, it is applicable for variational method also. It can be applicable for any other method. Here, this differential equation, this is a normal differential equation, fine. But now I am using a partial differential equation. I am taking a problem. Say one problem is given to me. For that particular problem, this differential equation is given in the problem. That problem satisfies this given differential equation. It can satisfy this equation also. It can satisfy this equation also. I am talking in general. If a differential
Okay,
equation
sir.
is given to me, then how to proceed for this weighted residual method? वो तो चेंज होगा आपका प्रॉब्लम टू प्रॉब्लम चेंज होगा ठीक है so what I can do is that from the concept of mathematics I can write like this del square del x square minus del by del x is equal to L. This L is known as differential operator which I am operating on variable u. Then I can write Lu is equal to F which is equation number 2. Is the equation number 2 clear? इक्वेशन नंबर 2 और इक्वेशन नंबर 1 में क्या डिफरेंस है समझ में आया
Yes, sir.
समझ
Yes,
में आ गया बाकी लोगों को समझ में आया इक्वेशन नंबर 1 और इक्वेशन नंबर 2 में क्या डिफरेंस है
हाँ सर.
ओके
सर और एक बार प्लीज बताइए ना
एक और बार बताता हूँ, ठीक है, देखो डेल टू यू बाई डेल एक्स स्क्वायर माइनस डेल यू बाई डेल एक्स इक्वल टू एफ ऑफ एक्स, फाइन। अब इसमें मैं क्या कर रहा हूं, ये जो आप देखो डेल बाई डेल एक्स, डेल बाई डेल स्क्वायर बाई डेल एक्स स्क्वायर, डेल बाई डेल एक्स, ये क्या है, ये एक डिफरेंशियल ऑपरेटर है। तो अगर मैं इसको बाहर ले लूं, ठीक है, कैसे लूं, एल इज इक्वल टू डेल
हाँ
स्क्वायर
सर,
बाई
समझ
डेल एक्स
समझ
स्क्वायर
गया, समझ गया।
माइनस डेल बाई डेल एक्स, दिस इज माई डिफरेंशियल ऑपरेटर। इसको मैं किसके ऊपर ऑपरेट कर रहा हूं, इसको मैं एक वेरिएबल के ऊपर ऑपरेट कर रहा हूं u, जो कि चेंज हो रहा है एवरी टाइम। देन from the concept of mathematics I can write that lu is equal to f, लिख सकता हूँ कि नहीं, हेलो,
हाँ सर, हाँ सर।
fine, lu is equal to f. Equation number 2 is nothing but equation number 1. I am writing it in more generalized form, fine. Now I told you that all these methods are approximation methods. That means if I want to find out the solution of this differential equation by this method, I have to assume one approximation function. Let that approximation function, that is u, is equal to u bar. U is equal to u bar. Now this approximation function can be anything. It can be a linear polynomial approximation function. It can be a quadratic polynomial. It can be a cubic polynomial. It can be a trigonometric function also. Normally, we choose polynomial approximation function. Why? Because polynomial approximation functions are easy to differentiate and integrate rather than trigonometric approximation function. But if in the question it has been given to you that solve the problem by taking suitable trigonometric approximation function, then you have to take the trigonometric function, or else you can take polynomial approximation function. Is the step clear?
यस सर।
ठीक है। अब आप क्या कर रहे हो, u आपका है एक्चुअल डिफ्लेक्शन इस प्रॉब्लम में, u बार आपका है अप्रोक्सीमेट सॉल्यूशन। तो अब आप जो आपका डिफरेंशियल इक्वेशन नंबर 2 है उसको आप रिप्लेस कर रहे हो एक अप्रोक्सीमेट सॉल्यूशन से। दैट मींस आई कैन राइट इक्वेशन नंबर 2 एज l ऑफ u बार एंड दैट विल नेवर बी इक्वल टू एफ। क्या वो उसके इक्वल होगा, एफ के इक्वल, क्या लेफ्ट हैंड साइड राइट हैंड साइड की इक्वल होगा? अगर मैं एक अप्रोक्सीमेट सॉल्यूशन लेता हूं, इफ आई अज्यूम u इज इक्वल टू u बार, क्या एलएचएस आरएचएस के बराबर होगा? हेलो,
नो सर, नॉट इक्वल। इफ
कभी
यू इज,
इक्वल नहीं होगा, इक्वल कभी इक्वल नहीं होगा। अगर इक्वल नहीं होगा तो मैं कभी सॉल्यूशन निकाल नहीं पाऊंगा। दैट मींस देयर इज एन एरर इन इक्वेशन नंबर 3। There is an error in equation number 3. This error will discriminate your actual solution from the approximate solution. That error in weighted residual method is known as residue or weighted residual function और error function। उस error को बोला जाता है रेसिड्यू और weighted residual function और error function। समझ में आया क्या है एरर फंक्शन? कोई डाउट किसी को? हेलो,
नो सर।
okay, I cannot continue further because it is 1 p.m. already, so I am stopping my lecture over here. Again we will meet on next Thursday, and from this portion we will continue our discussion. But before coming to the class on next Thursday, please read this lecture once again. I will post this recorded lecture in the Google Classroom. Please read it. Otherwise, because in the next lecture I will not repeat again from the starting point. Fine. आप पढ़ के आना तो आपको फिर इजी हो जाएगा यहाँ से समझने में। ठीक है,
सर अटेंडेंस सर अभी दिया मैंने, सॉरी।
कोई दिक्कत नहीं है, कोई दिक्कत नहीं है। ओके ओके, थैंक यू। इफ यू आर डन with your attendance, if you have written in the chat box, you can leave the meeting. Thank you.
Thank you, sir. Thank you.
Okay, 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 fine.